Welcome you all to the week 11 problem solving session of Basic Calculus 1. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of fractal geometry and dynamic systems. In today's problem solving session, we cover the topics volumes by slicing and volume of solid of revolution by the disk method and the washer method, and we do the illustration based on these topics. So let us start with the volumes by slicing. So in the first question, the solid lies between planes perpendicular to the x-axis at x equal to 0 and x equal to 4. The cross section perpendicular to the axis on the interval 0 to x lies between 4 are squares whose diagonal run from the parabola y is equal to minus under root x to y is equal to under root x. So in this question we have been told that the solids between the planes perpendicular to x-axis at x equal to 0 and x equal to 4, the solid, whatever will be the solid, so this is a rough figure of that. So the solid lies between x equal to 0, that is y-axis, and x equal to 4. So solid lies between these things, and it has been told that the cross section perpendicular to the axis on the interval 0 to 4 are squares. So it will be look like a cross section will be look like a squares. So if we try to draw these, so this will cross section will be like square. So this will be like this. So whatever will be the area, we need to think about area of a square. Okay, so what is the volume by slicing? It is x equal to a to b. Since it is cross section is perpendicular to the x-axis, so that is why we are putting limit x equal to a to b, and ax square dx. This is the cross section area. If you recall that, what was the area in earlier integration cases? It was something fx dx. So it was one dimensional, it was also one dimensional, so this contribute as two dimensional, whereas this is two dimensional and this is one dimensional, so this combined will contribute as three dimension, that is the volume. So this is just for knowledge. that we replace this functional value with this area square so that we can get the volume. So sorry, here will be Ex. So try this one. So this, since this is the volume of slicing, so whatever the solid is like this, and our solid will appear. The square will like this one. So what will be the area of this square? So if you will observe that here it has been told that square's diagonal should run from y equal to minus under root x to y equal to under root x. So what can be the length of the diagonal? Since it goes from minus under root x to under root x, so upper length will be under root x and lower length will be minus under root x. So it will be 2 under root x. Therefore, Ax is area of square. Usually we know that it is side square. So, but in terms of diagonal, it is d square by 2. So this will be 1 by 2, 2 under root x square. So this will give us 2x. Thus volume will be x equal to, what is the range of x? 0 to 4. 2x dx, that will give us 16 unit cube. Okay. Now in the same scenario, if we told the second one, the solid lies between the planes perpendicular. So let me just make one note here that its diameter starting from y equal to minus under root x to plus under root x. So it can be like this. So y square equal to x kind of equation is, it is like that. So it will be y based parabola from this cross section we made a square, this, and that starts from minus under root x and goes to plus under root x. So this length diagonal, I'm talking about diagonal, so diagonally it is like that. We're talking about its diagonal, so its diagonal is like this, minus under root x to plus under root x. So in this particular one, perpendicular to x-axis at x equal to minus pi by 3 and x equal to pi by 3, and the cross sections perpendicular to the x-axis are, the first one is circular discs with diameter running from the curve y equal to 10x to the curve y is equal to secant x. And the second, in the second one is, we are cross section are talking about in vertical squares of vertical square whose base, edges run from the curve y is equal to 10x to the curve y is equal to secant x. In the previous scenario, we have been given a cross section as a square that varies from y equal to minus under root x to plus under root x. But here, the cross section is perpendicular to x-axis are circular discs that whose diameter running from 10x to sec x. So you can say upper curve is sec x and lower curve is 10x. So by this we can calculate the diameter, and then we can find out the area of circular region, and then we can find out the volume. Whereas in the second part we have been given a squares whose edges are 10x to sec x. So from here we can calculate the side length. So it is the similar to the above one. You just need to take a caution that what is the area of that particular given cross section. Then you can find out the volume of the both of the parts. So try this one and we will discuss it. So let us start by doing this. As we are aware about that in both the parts, our curve is bounded from bounded below by this 10x and bounded above by sec x. So what will be the vertical length or vertical distance between the curves? Why we are calculating vertical distance? Because this solid is perpendicular to x-axis and we have been given the limit from x minus pi by 3 to plus pi by 3. So obviously we need to calculate only the vertical length. If we have been told that it is perpendicular to y-axis, then we should calculate the horizontal length. So the vertical length means distance. Vertical distance between the curves is 10x. So in a part, this length will play as a role of radius. Why? Because we have been told that diameter is running from this curve y equal to 10x to y equal to sec x. So since it's a diameter, this length is equal to diameter, thus radius will be secant x minus tangent x divided by 2. Thus area of cross section will be pi sec x 10x divided by 2 whole square. If you solve this a little, we'll get pi by 4 secant square x 10 square x secant x 10x. So this will give us 1 plus 2 10 square x or we may write like this one 2 times of secant square x minus 1 plus 2 times of sec x 10x. Now what will be the volume? Minus pi by 3 to plus pi by 3 ax, that is pi by 4 2 times of secant square x minus 1 plus 2 times of secant x 10x dx. So this will give us pi by 4. Now we have to integrate it. So calculate this integral. Let me know the value. So this will come out to be 2 times of 10x minus x plus 2 times of secant x. So this will be, so 10 pi by 3, so this will be 60 degree. So 2 times of under root 3 minus pi by 3 plus, and this will be 1 by 2 minus 2 under root 3 plus pi by 3, and this will be plus 1. So from here get pi by 4 under 3 and minus pi by 3. So this will give us the value pi under root 3 minus pi square divided by 6. Okay, now in the next part, that is B part, it is vertical squares of the base edges run from this to this. So we know the vertical distance. Now it will behave as base edges. So that means obviously side length S is nothing but sec x minus 10x. So the volume will be minus pi by 3 pi by 3. What will be the area if we know the side length and we know the cross section will behave as square? So this will be sec x minus 10x whole square dx. Again it is a whole square, so we can use the above calculation in the following manner. So it will be 2 times of secant square x minus 2 times of sec x 10x plus 1 dx. So again the above calculation will give us only this quantity, that is 4 under root 3 minus 2 pi by 3. So you can observe that both volumes are different. The reason is the cross section in the first part behave as circular disc, are the circular disc, and whereas in the second one is vertical squares. So cross section area will be different, thus the volume will be different. Now let us move to how to calculate the volume of solid of revolution. So third one is find the volume of solid generated by revolving the shaded region about the given axis. In the first part, it is about y-axis, x plus y 2, and this is a cross section. This intercept is 2, this intercept is 1. So first of all, before going to calculate this volume of solid of revolution, we should make recall what is the volume. So if you revolve this around y-axis, so this is your y-axis obviously, so if you will revolve this around, so there will become a cylinder of the form like this, which has this radius, or this is a kind of a cone. In general we call it as some solid of revolution. So here it will behave as a cone, and this was the area that we are being revolving around this y-axis. So what is the volume in general? That is A to B pi, that is the area that we have done above. What is V? A to B AX dx. Here AX is the cross section area, that is here as a circle. So this is pi r square. So what will be the radius here? So radius will be this line, arbitrary this line. So pi in terms of, you can say, radius, that is any function of x square dx. This is your fx that we have like that. So in this particular question, it will be, our radius will be distance from this point to this point. So since we are revolving around y-axis, so this was about x-axis. This was about x-axis. So in the same way, if we talk about y-axis, so obviously volume will be some c to d by some g of y square dy, and this will be your radius of revolving, and this will be your radius of revolving around x-axis. So here radius of revolving should be in terms of y. Thus x must be equal to 2 minus 2y. So you know the formula, you know how to calculate it. Just give it a try. So let us find out the volume of solid of revolution. So this will be, see, what will be the limit in terms of y? This intercept was 1. So, and it starts from 0. So 0 to 1 by 2 minus 2y square dy. Therefore, this will be 1. If we take 2 common, so this will be 1 plus y square minus 2y dy. So this will give us 4 pi y plus y cube divided by 3 minus y square, which will be from 0 to 1. So this will be 4 pi 1 plus 1 by 3 minus 1 minus 0. This will give us 4 pi by 3. Okay. So is there any calculation ever like this? Pi by 4, zero to 1. So 2 minus 2y, because x plus y, 2y is equal to 2, y 1 plus y square minus 2y, y plus y cube by 3 minus y square. Okay, 1 plus 1 by 3. Okay, so it's fine. Now what about if I will suggest you the shaded region as x-axis of a curve? See some region x is equal to 10 pi by 4, and this is by one line, and this is your shaded. So we want to revolve it around x-axis. Thus, whatever will be the solid, it will be this. It's a rough solid. So take form like this, and the radius will be, so random radius will be started from here, and it will go till here. So when x y is 1, so x will be 1 also. This point will be, or you can say this line will be x equal to 1, because at 1 10 y at y equal to 1, x will be 10 pi by 4, that is 1. So here you need to find out the volume. So let me give you just one hint that x will vary from 0 to 1, pi, whatever will be the radius, into dx. So try this one, and this radius should be in terms of x, so be careful. Here to make it this question a little easy, what we can do, we can take the rotation about y-axis so that the integration will become is easy a little. You can also do with respect to in perspective of x-axis, but here we are taking y-axis so that this will behave like, and in this scenario our y will vary from 0 to 1 and our radius at any point x will be, observe that what can be the radius will be this length, and you know that till this length this will be 10 pi by 4, but when you talk about and this whole length will be 1, then what will be the radius in terms of y? That will be 1 minus your 10 pi y by 4. Is it so? No, because this is in terms of x. This measurement we do in terms of x length when we are taking length with respect to this, but when we are take y length, so this will be should be like this. So this distance is exactly 10 pi by 4. So I just told you because to mention how the difference between the radii. So this will be, your volume can be now written as 10 square pi y by 4 dy, and you know how to integrate this one. This is not that much difficult. This will give us 0 to 1 secant square pi y by 4 minus 1 dy. So this will give us pi 10 pi y by 4 divided by pi by 4 minus y 0 to 1. So this will give us the value pi 4 by pi. 10 pi by 4 is 1 minus 1. When it's 0, this will be 0. So from here you get 1 4 minus pi. Okay. Now let me give you the one case that where the rotation is happening around x-axis. So this is kind of sin x graph into cos x. We have not given what is the value of x and what is the value of y where they are intersecting, that we have to get by our own, but we have been told that this will be your shaded area and what will be the revolution. So this will be like this. Just a second please. So this will be your solid of revolution where the radius will be this one. Now you just need to get what can be the limit. So it will starting from 0 and it will go to this something point. What can be that point? So it will be pi by 2 or it can be pi, that you have to guess. So first try that your own, then we will discuss it. So if you will observe that this y equal to, first of all we want to guess the limits. So this y equal to sin x into cos x. This is nothing but, from the graph you can also see that it is a sin x graph, some kind of sin x graph. So this will be sin 2x. So obviously this is the, you can say, identity of sine half angle formula. So this will be nothing but pi by 2. Obviously at pi by 2 it will become 0. So what will be the volume? This will be 0 to pi by 2. Pi into what will be the radius? This will be the radius, height. So this will be sine 2x divided by 2 whole square dx. So this will be pi by 4, 0 to pi by 2 sine square 2x dx. That can be written as pi by 2 1 minus cos of x divided by 2 dx. So this will give us pi by 8 x minus sine 4x divided by 4, 0 to pi by 2. So this will provide us pi square by 16. Clear? So till now we have seen that how to calculate yeah, how to calculate this volume of solid of revolution. So next question is based on similar kind of, but about, since here it was about x-axis, about y-axis, so it can happen, it may happen for some line also. So we can do that problem also. So let us discuss that. Next question is, in that scenario radius will be changed, nothing more than that will happen. So this was question number 3. So next one is question number 4. We write this one. So the region in the first quadrant bounded below by the line y is equal to under root 2. Sorry, here it will be bounded above and below by the curve y is equal to secant x into tangent x, and on the left by y-axis about the line y is equal to under root. So write it like this. Find solid volume of solid of revolution about y equal, about the line y equal to under root 2. So this is similar to the above one, just you need to get what will be the radius in this scenario. So try first, then we will discuss it in details. So let me just draw a diagram for you so that you will get to know what can be the limits and what can be the approach or what to get the radius. So this is your y equal to under root 2. Now what is y equal to sec x into tan x? So it will be kind of like this one. Okay, this is your intersection and this will be your area that you want to rotate around line y equal to under root. So in the resultant it will look like roughly look like this. So it can become like this, and the radius will be this one. Find the volume of solid of revolution about the line y equal to under root 2. So now try to guess the radius and try to do it. So let us discuss it now. So at random point y, this will be your radius. So obviously total length is under root 2. In the above example we also discussed how to discuss the height. So here the rotation is happening about y axis. Let me just confirm. Okay, so I guess there is a typo here. So here we have not changed it. The rotation is happening about x-axis. Then only we can put the limit like this. So this figure will be converted into now. Just give me a break. Okay, that was fine. I got just little confused with the rotation. Here it was about x-axis, that is the line x equal to 0. So whenever we talk about the line x equal to 0, then the limit should be in terms of y, but here it is about y equal to under root 2. So obviously the limit should be in terms of x. So your function should be in terms of x. So this is under root x, and this length is sec x into 10x. So what will be the radius of left part, you can say. So the radius will be, this height is sec x 10x. So minus term will be the height of inside this curve, that is under root 2 sec x into 10x. Now you got the radius. Now what will be the volume? So this is the intersection point. That should be the limit of your x. So what can be that? So obviously sec x into 10x should be under root 2. So obviously it will happen at x equal to pi by 4. So your x will be here pi by 4, and it's starting from 0. So 0 to pi by 4, pi into radius square, and radius is under root 2 secant x 10x whole square dx. So this will be pi 0 to pi by 4 2 minus, so this will be 2 minus secant square x 10 square x. So we may write alpha and should be in bracket, so that we can write here minus 2 under root 2 secant x 10x dx. Okay, so this will be pi times. Now we need to solve this one. So we know that so we should solve it like that. So 0 to pi by 4, 2 times of dx is nothing but times of x. 0 to pi by 4, that is pi by 2. Next one is 0 to pi by 4 secant square x 10 square x. This is our main problem, how to solve this one. So to solve this, we should write this like 10 square x to 1 plus 10 square x dx, and this will give us, so in this scenario whenever you take 10x equal to u, then dx will be 10x sec x square x. So in that scenario substitute u is equal to 10x. We are just trying, so can we get something? So du will be, or we can do directly here, we don't need to write like this, you can directly say it here. So when you substitute 10x, so du will be secant square x dx. Okay, so this will be u square du, but the limit should change as the rule of substitution. You when your x is 0, then u is 0. When your x is pi by 4, then u must be 1. So this will be 0 to 1, and this will give you 1 by 3 value. Whereas 0 to pi by 3, 2 under root 2 sec x 10x dx. So this will be 2 under root 2 secant x, and 0 to pi by 3. So this will give you the value 2 under root 2 sec pi by 3, that is 60 degree, is 2 minus sec 0 is 1, that is 2 under root. So ultimately volume will come out to be pi times, first value was pi by 2 minus second value was 1 by 3 minus plus 1 by 3 minus 2 under root. So I guess let me just confirm this answer. Sec x 0 to pi by 4. Okay, I guess we put a limit wrong here. So this was pi by 4, not pi by 3. So since this is pi by 4, so this will be under root 2 minus 1. So this will be 4 minus and minus 4 and plus and 2 under root. So this gives us value pi by 2 minus 11 by 3 plus 2 under root. This is the volume. Now let me give you one more problem in which also we need to find out the volume but around some different line. This is a similar kind of problem to the above one, so I hope it would not be difficult to solve for you. Fifth one is the region in the first quadrant. This is kind of a disk method because you are taking a disk and you are forming the cylinder from it and taking the radius. There will be some more method, that is a washer method, that we will follow from the next question. So this is last question I think about this method. So quadrant bounded above by the line y is equal to 2, below by the curve y is equal to 2 sin x, where x lies between 0 to pi by 2, and on the left of the y-axis. Now find the volume of solid of revolution about the line y is equal to. So you can observe that easily that this is the same kind of question. So but here this will be 2 sin x. So obviously this upper limit will be 2, and we have been told that this is y equal to 2 and this is pi by 2. So it has been told that we are rotating about y equal to 2 itself. Then what will be the solid that will look like? This will look like this. Let's give you a and this will be your kind of radius at any time. Now just a second. Yeah, now it will look like this. You can draw it this kind of this, and this is your volume of solid of equation, and this is your radius, and obviously you have to integrate 0 to pi by 2. Now just you need to think about what will be the radius similar to the previous one in this case scenario. That is the only task. So let us discuss this one. Similar to the above one, the radius will be, so in this case, let us mention what is the radius. So this is the radius at any time. So the whole length is obviously 2, and this much length is the curve, that is 2 sin x. So the left length will be the radius. So the radius will be 2 minus sin x. The volume will be 0 to pi by 2 pi 2 minus 2 sin x whole square dx. This will come out to be 4 pi by 1 plus sin square x minus sin x. So from here, this will be, let me just write it, 1 plus 1 minus cos x divided by minus 2 sin x 4 pi. So 1 plus 1 by 2 will be 3 by 2. So this will be 3x by 2 anyway. And this will be sine 2x divided by 4. And this will be minus, or in fact plus, cos x from 0 to pi by 2. So from here we will get 4 pi, 3 pi by 4. This will be 0. And cos pi by 2 is 0. Negative sign 0, 0, minus 2, and this will give us, you can see, 3 pi square minus, in fact plus 8 pi. Let me just verify it. So I think, okay, there was plus sign here, so this will be minus now. Okay, so this is all about how to find out volume by the disk method. Now let us learn how to apply this washer method, in which case scenario the washer method is applied. So first of all, we do a simple question, that where the volume of revolution is happening around, you can say here, x-axis. Then we will discuss the where the volume of revolution will happening around some more general, you can say any y equal to line axis, y equal to 2 or something constant sum. So this was question number 5. Question number 6 is the region in first quadrant bounded on the left by the circle pi square 3, and on the right by the line x is equal to under root 3, and above by the line y is equal to under root 3. Now find the volume of the solid of revolution around y-axis. Y-axis means obviously x equal to 0. So whenever x equal to 0 happen, then we should do the integration in terms of y. So let me just draw a rough diagram for you here. So x square plus y square equal to 3. So we want to talk about only in the first quadrant. So it should be like this. This is under root 3 comma 0. This is 0 comma under root 3. And y equal to under root 3 is like this. And x equal to under root 3. So this is your portion. And you are rotating around y-axis to this one. So this will be like this. Like this one. This can be some form of solid. And here the radius will be 2 in terms of y. So if you will observe that in general, if I told you this is pi sum ry minus this ry square minus small ry square. This is the volume of, you can say, washer method, volume by washer method. So here, what is your above ry, the upper curve, that is x equal to 3. What about the lower curve? That will be x equal to under root 9 minus y square. And you know, clearly know the limit, it is bounded above by under root 3, then it should go 0 to under root 3. So it kind of, you can say, upper curve minus lower curve kind of thing. So this will be 0 to under root 3, limits in terms of pi under root 9 minus y square whole square minus under root 3 square dy. So this will give us pi 0 to under root 3 9 minus y square minus 3 dy. So this will give us pi 6y minus y cube divided by 3 from 0 to 3, and this will give us pi 6 under root 3 minus under root 3, that is 5 under root 3 pi. So I hope there is no such calculation. Okay, we made a mistake again. So here it was upper curve is x equal to under root 3. Thus this should be under root 3 minus this thing. So it should be like this. Should come like this. So because of this one, this factor will become 3 minus, okay, that was 3 x square plus y square is equal to 3. 3 minus 3 minus y square. So obviously 3 will cancel out, you will left with only y square. So that integral will be like this. And from here you will get exactly under root 3 pi, or you can say pi under root 3. So we just need to be cautious with our calculation. Now in this we have rotate around y-axis. What about if we rotate around some line? So if in next question we will see that line should be I guess x equal to minus 1. So next question is question number 7. So in this the region, so I will not write it again, just try to replace the quantity in this. Rather than we will invest the time to explain the things. So it is like this one. So this is the region, and what we are going to update bounded here. We talk about bounded left or right, then but in this case we are talking about bounded above by the curve, bounded by curve y is equal to square, and below and below by the x-axis. Okay, and next is and on the right by the line, and on the right by the line x equal to 1. So what have been asked that find the volume of the solid of revolution about the line about the line x equal to minus 1. Okay, so let me just draw a rough diagram here. This is y-axis, this is x-axis. So it has been told that bounded above by this curve y is equal to x square, okay, and below by x-axis, and x equal to 1 is here, okay, and x equal to minus 1 is here. So we are only talking about the first quadrant. So we have been told that we are rotating this one around this x equal to minus 1. So obviously radius will play a role. Earlier it was axis of reference will be was y-axis. So we will not have to take care of that. Here it plays a role in finding out the radius. How? Let me just give you one hint regarding that, then you will try at your own how to solve this one. So in the first case, what is this curve? X equal to 1. Earlier this length was 1, but now axis of reference is x equal to minus 1. So this should be this much minus this much. So capital R x, and we are rotating about the x-axis. So this curve should rotate around like this, but this should be this axis of reference. So you can see, okay. So this will be 1 minus minus 1, and whereas small rx will be the length of this curve minus 1. And what is the length of the curve? X square. So in terms of y, if you will see under root y, since we want to rotate around x equal to minus 1, so because around x equal to minus 1, thus this will not happen like this will happen around x equal to minus 1, this will happen around that y-axis, because x equal to minus 1 is vertical line, so it will be around y-axis. So it should be in terms of y itself. So under root y minus x y. This will be 2, and this will be under root y plus 1. Okay. Now you have to find out the volume. You should guess what was the limit and put the value of ry. There should be ry rather than rx. This is 2 square minus under root y plus 1 whole square dy, and what can be the limit y? Obviously 0, and this will be at x equal to 1, y will be 1, so this will be 1, Now you just need to solve this one and quickly tell me the answer. So this will be pi 0 to 1 3 minus y plus, or in fact minus 2 under root y dy, and this will give us pi 3y minus y squared by 2 minus this will be by 3y to the power 3 by 2 0 to 1. This will be pi 3 minus half 4 by 3, so this will be pi 6 18 minus 3 minus 8, so this will be 7 pi by 6 if we have not made any calculation, so it is correct, 7 pi by 6. So till now we have learned how to calculate volume by slicing, volume by disk method, and volume by its washer method, volume of solid of revolution if I would say, about the last two approaches. So now let me give you the one last question that will combine all the kind of problems. So there will be four subparts. So question number 8, I guess. Just a second. 6, 5, 4, 6, 7, 8. In this there are four subparts. So find the volume of solid generated by revolving the region bounded by y is equal to under root x and the lines y is equal to 2 and x is equal to 0 about. Now around which axis we are rotating, that we have been explained or asked in four subparts: x-axis, y-axis, c1 is y equal to 2 and d part is x is equal to 4. So this is, you can say, a conclusion of all our questions. So try this one, then try these four, then we will discuss all of them. So I'll give you one hint here. First of all, we are rotating about x-axis. So curve is bounded by y equal to under root x, y equal to 2 and x equal to 0. So y equal to under root x means y square equal to x is a curve. The root x means it's in the first quadrant. This is y equal to 2 and this is x equal to 0. So this will be your shaded region. Around x-axis means, so this should be like this. Should be the solid volume of revolution. And at any point, since we are talking about x-axis, that is y equal to 0, then our y should vary from 0 to is 2 and this is any random radius. Okay, and we are talking about around y x-axis. Then you have to think about what can be our r of y, can be our small r of y. Okay, wait. Just this is the length we are talking about. So if you will observe that this is length around x-axis, not the height. This is the horizontal length. So this should be x-axis in terms of x. So these kind of confusion will occur. So you just need to make sure how you are measuring the radius. That will give you the answer what should be in terms of x. Here you are measuring in horizontal way, so therefore your limit should be in terms of x. Whenever you measuring in terms of vertical way, then it should be in terms of y. So let me make a recall of theory, because of we are getting confusion here many times. So suppose in this example, this is your curve. Whenever we talk about around x-axis, so that means the rotation will around happen like this, that we have to rotate around x-axis. Therefore the length should be like this. Okay, whenever it will be around y-axis, suppose, so this curve will become like this one and this will be your radius. So it will be measured like this. Since it's measured like this and this varies from 0 to this one, so it will be in terms of y. Since we are measuring like this, it should be in terms of x, as it will go x0 to something this one. Okay, whenever it will be around some line, then we have to deal with in that scenario. Okay, this is just for sake of no confusion occur again. So what is capital Rx? So if you will observe that this is bounded above y equal to 2 above curve, so it will be in terms of 2. The lower one will be that will be under root of x. Okay, what Washer method says, the volume will be pi x ranges from 0 to, recall that this is y equal to 2. So y is 2, then what will be x? Under root 2 or 4. X will be 4 because y is under root x. So this will be 0 to 4. Capital R square. Capital R means here 2 square minus under root x square dx. This is around x-axis. Whenever around it x-axis, this should be dx. Whenever around you can say y equal to something line that is parallel to x-axis, then should be dx. So this will give you 0 to 4, 4 minus x dx, and that will give you the value 4x minus x square by 2, 0 to 4. So this will be pi 16 minus 8, that is 8 of pi. Now if this case arise for E part, that is about y axis, so how the things will occur? So this is y equal to 2, this is y equal to the root x, this is your area, shaded portion, and this will be like this. Okay, so in this scenario the radius will be like this, measure like this. Okay, so capital R of y will be y square, small r of y will be 0, because this is x equal to 0, because in terms of we write anything na, x equal to f1y upper curve and x equal to f2y, that is lower curve. So volume will be 0 to 2 pi y square whole square minus 0 square into dy. So it will give you pi y to the power 5 by 5, 0 to 2, it is 32 pi by 5. Now the C part, in C part we are rotating around y equal to 2. As I told you, y equal to 2, that is a vertical line. Vertical lines means the limit should be in terms of y. So this is y equal to 2, and we are rotating around this y equal to 2 line. Now not y y equal to 2 line. So this curve will should appear like this one. This is like this. Okay. So y equal to 2 line. C part is about y equal to 2 now? Yeah, y equal to 2. So C part y equal to 2. So it is parallel to which line? Horizontal line, x equal x axis, that is y equal to 0. So what can be the radius? Let me just make a big diagram. This is a bit messy. See, this confusion will clear that which limit we should take by the practice, or you can say by the observation of your diagram. So this is like this, and this is your shaded area, and this is your complete y equal to 2, and this is y equal to x. You want to rotate around y equal to 2. So if you want to rotate around this one, this will be your radius that you have to measure it. Okay, so what can be the radius in this scenario, and how can you measure it? So since it is around directly, since it is parallel to horizontal line, so above observe that where our axis was parallel to horizontal lines, this one, this case, so obviously it should be in terms of x. So how we can see that what will be our radius, that you have to judge it here, that is what is capital Rx and what is small rx. Okay, So in this scenario, earlier our axis, where axis of reference was x-axis, here axis of reference was 2. So obviously, and our curve was bounded by above by y equal to 2, below by this one, and x equal to 0 that we are talking about. So obviously the closest to y equal to 2 is itself y equal to 2. So inner circle will be, radius of inner circle will be 2 minus 2, that is 0, it is itself. And radius of outer circle is 2 minus under root x. Therefore the volume will be x 0 to this was 4, if you remember in the first case, 0 to 4 pi 2 minus under root x whole square minus 0 square dx. See, whenever you have to do the integration, that you have to judge by drawing the diagram, or you can see some reference, that is it is told about parallel to the horizontal line, so it will be in terms of x, and if it is parallel to the vertical line, then it should be in terms of y. So this will give you 4 minus x minus 2 under root x dx 0 to 4. So this will give us value pi 4x minus x square by 2 plus minus 4 by 3 x to the power 3 by 2 0 to 4, and this will give you the value 16 plus 8 minus, this will be 8 32 by 3. So 16 plus 8 is 24, and 96 minus 32, that will be, I guess, 6, if our calculation is correct. So this is 24. Okay, 24 to the is 72, not 96. So this will be you can say, is it 2 or 64? Let me just check it. Was a C part, 8 by 3, it should be 3 by 2. Okay, here it should be 4. It should be 4, and this should be 8. Therefore this should be 64, and therefore this should be 8. So your answer will be 8 pi by 3. Okay, now in the last part we have been told x equal to 4, see around x equal to 4. So obviously x equal to 4 will be x y, x equal to 4 will be like here something. Okay, oh no, sorry, x equal to 4 itself the intersection point. Okay, wait, yeah, so this will be your x equal to 4. So we are rotating around x equal to 4 this time, and this is parallel to your vertical line. So you need to see r in terms of y, small r in terms of y. So obviously this distance will be the maximum, and this will be the smaller one. So in this scenario you have to see the what will be your limits, and obviously volume limits will be 0 to 2 and pi capital ry square minus small ry square, but this case scenario that we have to see it here. So to see this one, so if you will observe that this outer radius is nothing but 4 exactly, and while this one you know that this is 4 minus y square, so this will be square minus 4 minus y square square. So this will give you the value 0 to pi 0 to 2 pi 16 will cancel out, and this will be 8y minus y to the power 4 dy at 8y square. This will be by 8y cube divided by 3 minus y to the power 5 by 5, 0 to. So this will give value 80 plus 60 divided by 3 plus 2 divided by 5. So this will give 225 by 10. So that's all about today's session. I'm again repeating, whenever your volume of solid of revolution is any axis that is parallel to the vertical line, then each limit should be in terms of y. Whenever it is parallel to the horizontal line, then limit should be in terms of x. Okay. If you have any doubt, then please ask. Otherwise, let's end today's session here.
Sir, next week
Sorry.
there will be session or not?
Yeah, there will be one more session that is going to be our last session of this course.
Okay, sir.
Okay, okay then. Thank you.